What if you need to convince your fellow developers, sysadmins, that containers are great because they're like, I'm not too convinced about this whole shipping industry metaphor, and what does that really mean for me to use containers? So the kind of getting started with containers, the high level battle plan is, okay, so you have this software component that is a giant pain to deploy because we have tons of dependencies, different libraries, packages, etc. Well, we are going to fix this, and we are going to fix this way. First, we are going to write the instructions to install that on a little README, like the install.txt file, because we should be able to do that. Maybe it won't be perfect. Maybe some instructions will have to be a little bit vague in the beginning, but let's start with that. Then from that point, we write a script that will work for us. Works for us means that we know that environments are going to be different. Like this laptop is running Arch Linux, and I don't expect many folks to be running Arch Linux. Like maybe they will be running Debian or Ubuntu or Fedora or CentOS, or maybe they won't even be running Linux at all. But never mind, I'm going to write my installation script that works for me, and that should be doable, because the problem with installation scripts is when you have a Debian machine, you use apt-get, and with a Fedora machine, you use yum, etc., etc. Let's not worry about that. Let's do something that works on my machine. Then I can turn that into a Docker file. A Docker file is a recipe to build a container, and we will see exactly what this looks like. But as you will see, once you know how to write a shell script, it's pretty easy to write a Docker file from that. Now, once this Docker file builds on my machine, it will run everywhere. If I write my Docker file to build my application, and I can get this Docker file to build on my machine, then I have like the 99% guarantee that it will run on every other Docker machine on the planet, regardless of the distro, operating system, etc. My Docker file will build on my Mac, on a Windows machine, etc., etc. So now that I have this Docker file, I add it to my code repository, and then my getting started instructions, instead of being this long README file, it's clone the repo, run this docker build command, and that's it. Now your container is ready, and it can run. So that's the high level overview. And then when we go a little bit farther, we extend that with Compose, which lets us manage stacks of multiple containers. And then my onboarding process, when I either welcome a new developer to the team or when I start working on a new project, it becomes 3 instructions. Number 0 is have Docker set up on your machine. Then number 1 is clone the repo, and number 2 is Docker Compose up, and that's it. And this will work everywhere. I can do that on my Mac, I can do that on a Windows machine, I can do that on any Linux machine with Docker installed, and it will work. So that's the getting started phase. And once we have that, we have lots of low-hanging fruits that we can pick. We can use that to build a reliable, fast, continuous integration pipeline. We can use containers as build artifacts. We can say, okay, each time we make a build, we are going to keep that container image on the side. So later, if we have a problem and we're like, oh, did that problem exist with the version that we built 3 weeks ago? Well, instead of rebuilding that version from 3 weeks ago and hoping that we get the same build, we can just go to that library of containers and get the exact build that was running 3 weeks ago and see if the bug is in that build or not. We can also decouple plumbing for application logic, and that sounds a little bit vague, and I will show just a little bit of that in the workshop today, but we'll see that it lets us separate different components. I can have a web front end that talks to a database, and if I need to scale up that web front end by adding a load balancer, or if I need to replace that single server database by a replicated system or by something hosted elsewhere, etc. With containers, I can do that very easily without having to kind of dive into my code and my configuration everywhere to update everything. So then there. I forgot to mention, when you see the slides with this little, this is supposed to be a magnifying glass. Those slides have like extra bits of information that is not strictly essential. So sometimes I will arbitrarily skip some of these slides because I'm like, no, I think it's okay, we can skip that. But I still leave them in the deck so that you can have more info. So for instance, this is a good example of I'm going to decide to skip these slides because I don't like them. But it is just a little comparison of what we had before Docker and after Docker in terms of API and what containers looked like. And I often make the point that Docker did not really innovate in the sense that Docker did not invent containers. Docker did not invent the big metal box in which we put things. Like, people were putting things in boxes for ages, and in the software industry that means people were putting software in packages and tables and zip files for ages. But what Docker really invented, so to speak, the real innovation was to decide on a common format and make that format super easy to move around, so that anybody could get started with containers instead of having containers being that kind of dark arcane science that is only mastered by the people who run Solaris and FreeBSD and maybe a few really specialized Linux things. So that was really the innovation behind Docker.